Metals and non-metals. Metals and non-metals. Bronze, steel, metal sludge, brass, aluminum, cast iron, copper. Table of content. Properties of ionic compounds, metals versus non-metals, malleability, ductility, metalloids, chemical properties of metals, reaction with oxygen, amphiphotic oxides, reactivity of different metals towards oxygen, sodium and potassium, magnesium, aluminum, zinc, lead, iron, copper, silver and gold, reaction with water, reaction of some metals with water, reaction of metal with acids, reaction of metal with dilute HNO3, aqua regia, reaction of metals with solutions of other metal salts, chemical properties of non-metal, reaction with oxygen, reaction between metals and nonmetals, ionic bond formation, covalent bond, electrovalent bond, ionic bond formation of sodium chloride, properties of ionic compound, physical nature, melting and boiling points, solubility, conduction of electricity, occurrence of metals, corrosion, prevention of corrosion, formation of alloy, steps involved in extraction of metals from ores, metallurgy, reduction of metal, thermite reaction, electrolysis, electrolytic refining. Metals, non-metals. Metals, they are generally solids. Exception: mercury Hg is liquid in room temperature. Cesium Cs 28.5 degree, gallium Ga 30 degree. They have metallic luster, shine. Exception: lead Pb. They are generally hard. Exception: alkali metals like lithium, sodium, and potassium. Alkali metals. Alkali metals, they are soft metals that can be cut with a knife. They have high melting point and boiling point. Exception: gallium and cesium. They are malleable in nature. Gold, Rm, and silver Ag are most malleable metals. Example: sweet coated with thin sheets of Ag foil, silver foil. Okay. Exception: Hg, mercury, sodium, potassium, zinc. Mercury liquid, sodium potassium soft, zinc brittle. They are ductile in nature. Gold is most ductile, Rm, Au. Exception: mercury, sodium, potassium, zinc. They are sonorous in nature. Make or produce sound. Example: school bell, school bells, temple bells, etc. They have high density. Exception: osmium, high density, sodium and potassium. They float on water. They form alloys. Examples: stainless steel alloy of nickel, chromium and iron, German silver, copper, zinc, and nickel. Metals are good conductors of heat and electricity. Exception: lead and mercury. Silver more than copper. Good conductor of heat. Free electrons are required for for conduction of electricity. They show cationic properties. Metals form metal oxides when react with oxygen. Generally, all metallic oxides are basic in nature. Non-metals, they are generally solids or gases. Exception: bromine, liquid at room temperature. They are non-lustrous. Exception: iodine, diamond, graphite. They are generally soft. They have low melting point and boiling point. Exception: diamond, hardest nature substance known. Hardest natural substance known. Graphite, silicon, carbon, boron. They are not malleable in nature. They are non-ductile. They are non-sonorous. They have low density. Exception: diamond. They do not form alloys. Exception: carbon is alloyed with iron to form steel. They are bad conductor of heat and electricity. Exception: graphite, which is good conductor of electricity. They show anionic properties. Non-metals form non-metallic oxides which react with oxygen. Generally, all non-metallic oxides are acidic in nature. Metals: gold, copper, silver, mercury, lead, magnesium, titanium, iron, zinc, sodium, cobalt, tungsten, aluminum, potassium, platinum. Sulfur and non-metals: sulfur, bromine, carbon, oxygen. Malleability: it is a physical property of metals that defines their ability to be hammered, pressed, or rolled into thin sheets without breaking. Example: gold. 1 gram gold can be drawn into a wire that is about 2 kilometers long. Ductility: it is a material ability to deform permanently. Example: stretch, bend, or spread in response to stress. Example: most common steel most common steels. Metalloids: having intermediate properties between metals and nonmetals. 7 metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Boron, silicon, germanium, arsenic, antimony, tellurium, and polonium image is not there. Chemical reactions of metals: reaction with oxygen, burning in air or formation of oxides, combustion. Almost all metals combine with oxygen or air to with oxygen to metal oxides. Metal plus oxygen metal oxides. Example: 4 aluminum plus 3 oxygen gas gives 2 moles of aluminum oxide. 2 moles of copper solid plus oxygen gives copper oxide. Generally, metal oxides are basic in nature. Physical property: metal, non-metal. Conductor of electricity: metals yes, non-metals no. Exception: graphite. Conductor of electricity: metals yes, non-metals no, except graphite. Malleability: can be beaten into a different shapes with a hammer. Metals yes, non-metals no. They are brittle, break easily. Ductility: can be drawn out into wires. Metals yes, non-metals no. They are brittle, break easily. Lustrous: has a shiny surface when polished. Metals yes, non-metals no. Very dull surfaces. Sonorous: makes a ringing sound when hit with a hard object. Metals yes, non-metals no. They make a dull sound. Mixed oxides that are basic in nature. Amphoteric oxides. They are both acidic and basic in nature. Example: zinc oxide, aluminum oxide. Al2O3 plus aluminum oxide plus hydrochloric acid gives aluminum chloride salt plus water. Aluminum oxide plus sodium hydroxide base gives sodium aluminum oxide salt plus water, or sodium aluminate plus water. Other examples with tricks: Suno SnO2, beryllium BeO, Sunobe Janabe Ali फिर मिलेंगी गली में. Sunobe Janabe Ali फिर मिलेंगे गली में. Other examples are of amphoteric oxides: SnO, BeO, ZnO, Al2O, Al2O3, PbO2, MnO2, Ga2O3. Most metal oxides are insoluble in water. Some metal oxides are soluble in water and form alkali. Those based, those bases, those bases that dissolved completely in water. Alkali like sodium oxide, Na2O, potassium oxide, K2O. Reactivity of different metals towards oxygen. Sodium and potassium react so vigorously with oxygen that they catches fire if kept in open. That's why they sodium and potassium are kept in kerosene. Magnesium, aluminum, zinc, lead. At room temperature, at ordinary temperature, the surface of metals get covered within thin layer of oxides. The protective layer prevents them from further oxidation. Iron, it does not burn on heating, but iron fillings burn vigorously when sprinkled in a flame of burner. Copper does not burn, but the hot metal coated with a black layer of copper to oxide. Silver and gold. does not react with oxygen even at high temperature. Conclusion: sodium most reactive, most towards oxygen, most reactive metal towards oxygen. Reactivity series or activity series of metals: potassium, sodium, barium, calcium, magnesium, aluminum, zinc, iron, nickel. These metals are more reactive than hydrogen. And tin, lead. Okay. And with hydrogen, copper, mercury, silver, gold, platinum. These metals are less reactive than hydrogen. Potassium, more reactive metal. Mm, so potassium, sodium reacts vigorously with the cold water, highly exothermic. And barium, calcium, magnesium react vigorously with hot water. And aluminum, zinc react vigorously with steam, decreasing chemical reactivity. And iron, nickel, antimony, lead, hydrogen, copper, mercury, silver, gold, platinum. No reaction with any type of water. Least reactive metals. Reaction with water. Metal plus water form metal oxide plus H2 gas. All metals do not react with water. Metal oxide plus water. Metal hydroxide. Potassium and sodium. Cold water, hot water, steam. Calcium. Okay. Potassium and sodium react vigorously plus exothermic. Evolves H2, catches fire, reacts with hot water and reacts with steam. Calcium, less less violent reaction, plus exothermic, react with hot water and steam. Magnesium, no reaction with cold water. And Mg starts magnesium starts floating in hot water. It happens because the bubbles of hydrogen gas formed in the reaction stick to the surface of the metal and react with steam. Aluminium, iron, zinc react no reaction with cold water, no reaction with hot water, and reaction with steam. Lead, copper, silver, gold. No reaction with cold water, no reaction with hot water, no reaction with steam. Reaction of some metals with water. 2 potassium solid plus 2 H2O gives 2 KOH aqueous plus H2 gas plus heat. 2 Na plus 2 H2O gives 2 NaOH aqueous plus H2 gas plus heat. Calcium solid plus 2 H2O gives CaOH2 aqueous plus H2 gas. 2Al solid plus 3 H2O gives Al2O3 solid plus 3 H2 gas. 3Fe solid plus 4 H2O gives Fe3O4 solid plus 4 H2 gas. Reaction of metal with acids. Except a few less reactive metals such as copper, mercury, silver, gold, platinum, etc. All metals react with dilute sulfuric acid and hydrochloric acid to produce salt and hydrogen gas. Metal plus dilute acid gives salt plus hydrogen. Metal M plus A gives S plus H. Zinc solid plus 2 hydrochloric acid aqueous gives zinc chloride aqueous plus hydrogen gas. Reaction of metal with dilute HNO3. Hydrogen gas is not evolved when a metal reacts with nitric acid, HNO3 nitric acid reacts with nitric acid. This is due to strong oxidizing nature of nitric acid. It oxidizes the hydrogen produced to water and itself get reduced to any of the nitrogen oxide NO, NO2, N3O. But magnesium Mg and manganese Mn react with dilute HNO3 to evolve H2. Dilute solution A 1 ml acid and concentrated solution B 5 ml acid. Metal plus HNO3 gives salt plus NO2 or N2O or H2O. Exceptional case only for manganese and magnesium. Metals Mn or Mg plus HNO3 gives a salt and H2 gas. Note: copper does not react with dilute hydrochloric acid. Aqua regia, royal water. It is a mixture where two acids are in the ratio concentrated hydrochloric acid and concentrated nitric acid in 3:1 ratio. It is highly corrosive in nature. Aqueous regia is able to dissolve gold and platinum. Reaction of metals with solutions of other metals. Metal 1 plus metal 2 salt gives metal 1 plus metal 2 salt gives metal 1 salt plus metal. This is displacement reaction. And copper plus 2 moles of silver nitrate aqueous gives copper nitrate and 2 moles of silver. The more reactive metal replaces the less reactive metal. Chemical properties of nonmetals. Reaction with oxygen. Nonmetals do not react with water, steam, or dilute acid. The reaction is that they act as a electron acceptor and cannot accept cannot accept H plus ions of acids to reduce them to hydrogen gas. But on heating readily form oxides of salt with concentrated acid. Sulfur plus 2 moles of H2SO4 concentrated on heating gives 3 moles of SO2 gas plus 2 moles of H2O liquid, and sulfur solid plus 6 moles of HNO3 concentrated on heating gives H2SO liquid plus 6NO2 gas plus 2H2O aqueous. Reaction between metals and non-metals ionic bond formation. Sodium will donate electron. Sodium configuration 281, chlorine configuration 287. Chlorine requires an electron. Sodium has one electron, extra electron. Chlorine requires an electron. Okay. Lewis dot structure, Lewis dot structure or electron dot structure. These both. And electron bond formed. Sodium plus and chlorine minus. Electron sharing. Sodium. When sodium transfers an electron to chlorine, it results in sodium chloride. Sodium atom with 11 electrons and 11 protons transfers its single valence electron to chlorine atom with 17 electrons and 17 protons. Chlorine. Na becomes positively charged and chlorine atom becomes negatively charged. Electrovalent bond. An electrovalent bond, also known as ionic bond, is a chemical bond and forms when electrons are transferred from one atom to another. Ionic bond formation of MgCl2. Magnesium chloride. Mg plus 2Cl gives rise to MgCl2. Chlorine, magnesium, chlorine gives magnesium, chlorine, chlorine. Atom 1 metal and atom 2 non-metal. Transfer of electrons gives ionic molecules A plus. And Mgx plus Cl and Cl gives Mg2 plus and 2 moles of Cl or MgCl2, and Mg2 plus 2Cl minus gives Mg2 plus and 2Cl minus or MgCl2. Ionic bond formation of NaCl. Sodium metal transferring the electron to the chlorine atom. There is no sharing of electron exist in sodium chloride compound. And next, ionic bond formation in sodium chloride due to complete transfer of electrons from sodium to chlorine atom. Na plus Cl minus. Ionic compounds show anisotropic properties. Ionic compounds show anisotropic properties. Properties of ionic compounds. Physical nature. Ionic compounds are hard crystalline solids because of a strong force of attraction between the positive and negative ions. These compounds are generally brittle and break into pieces when pressure is applied. Melting and boiling points. These compounds have high melting points as large amount of energy is required to break strong interionic attraction. Solubility. These compounds are soluble in water, polar solvent. and insoluble in organic solvents, non-polar solvents like kerosene, benzene, ether, petrol, etc. Conduction of electricity. The conduction of electricity through a solution involves movement of charged particles, ion and charged particle. Ion and electrovalent compounds are good conductors of electricity. Ionic and electrovalent compounds are good conductors of electricity, but they conduct electricity either in molten form or in their aqueous solution. Occurrence of metals: aluminium, bauxite, uh, cryolite; iron, magnetite, hematite, limonite, siderite; zinc, zinc blende, uh, sphalerite, sphalerite; calamine, zincite, zinc; mercury, Canberra; thorium, monazite; sodium, borax, Chile and Indian saltpeter; KNO3, throwan; lead, galena; magnesium, Epsom salt; MgSO4, 7 into 7H2O; tin, cassiterite; uranium, pitchblende. It is made up of uranium oxide, UO2, and variable properties of U3O8. Ore has metal plus gond. Ore has metal plus gonds impurities. Corrosion. Silver. Black coating formed due to silver sulfide formed by reaction of silver with sulfur in air. Copper. Green coating due to basic copper carbonate formed by reaction of copper with carbon dioxide in air. Iron. Reddish brown coated color called rust. Iron collide rapidly in air and water. Black coat on silver spoons. Titanium is used for making boat because it does not corrode in seawater. Prevention of corrosion. Galvanization. Protecting steel and iron from rusting by coating them with a thin layer of zinc. Anodizing. Process of forming thick layer of oxide of aluminum. Metals like aluminum, magnesium, titanium can be oxidized by anodize. Used in aircraft industry. Fact: aluminum is more reactive than iron, but aluminum is less easily corroded by iron because oxygen forms a protective oxide layer. Formation of alloy. Brass. Copper 80% plus zinc 20%. Bronze. Copper 88%, selenium 12%. Solder. Selenium plus lead. Bell metal. Copper plus selenium. Gunmetal. Copper plus selenium plus zinc. Amalgam. Mercury plus other metals. Stainless steel. Iron plus nickel plus chromium plus carbon. Constantan. Copper plus nickel. Manganene. Copper plus nickel plus manganese. Nichrome. Nickel plus chromium plus manganese plus iron. German silver. Copper plus nickel plus zinc. White gold. Aluminum 75% plus nickel plus lead. White gold. It was originally developed to imitate platinum, a naturally white metal. Magnesium. Aluminum 95% plus magnesium. Duralium. Aluminum 95% plus magnesium plus manganese plus copper plus carbon. Jewelry made of gold is an alloy. Pure gold has 22 carats, 22 parts of gold, 2 parts 22 parts of gold, 2 parts of copper or silver. Amalgam. It is a metal alloy of mercury with one or more metals. With one or more metal. Steps involved in extraction of a metal from ore. Metallurgy. It is a process that is used for extraction of metals in their pure form. Ore. Concentration of ore. Metals of high reactivity. Electrolysis of molten metal gives pure metal. Metals of medium reactivity, carbonate ore or sulfide ore, and carbonate ore on calcination. It is done in in the absence of oxygen, and sulfide ore in a process of roasting. It is done in the presence of oxygen. They gives oxide of metal, and next gives reduction on reduction of metal gives purification of metal. Metals of low reactivity, sulfide ores, roasting, metal, refining. Reduction of a metal, 2ZnO gives 2ZnO plus carbon gives 2Zn plus CO2. Zinc loses oxygen, carbon gains oxygen. Thermite reaction, it is a type of reaction in which a metal oxide is reduced by using aluminium as a reducing agent. It is generally exothermic in nature. Iron oxide plus aluminium on heating gives molten oxide and aluminium oxide. Aluminium reducing agent. Iron oxide reduces to molten oxide. Iron. And next aluminium on oxidation becomes aluminium oxide. Example, railway track or joint uh, railway tracks are joined using this reaction. Electrolytic refining, it is a process that uses electricity to purify impure metals. An impure metal is used an anode and a pure metal is used a cathode. A solution of a solution of a metal salt is used as an electrolyte. When electric current is passed through the cell, the impure metal dissolves into the electrolyte and is replaced by an equal amount of pure metal from the cathode. Anode impure metal, anode mud, cathode pure metal, copper sulfate solution. The pure metal is deposited at the cathode, while the insoluble impurities from the impure metal settle down beneath the anode as anode mud.